folks. This is me, Vishwas Nayan. I'm the host of this podcast. Over a course of time, there are ways in which you can architect a solution with big data, data engineering, and it's a bigger piece of a puzzle which is still unknown. Is that can we really architect using software in the right way? That's the biggest challenge in all the software problem statement that comes up. So here I'm with Saurabh sir. Over a course of time, you'll realize that we'll be covering topics regarding feedback loop in your large scale system. We'll obviously be covering about intelligent system and the features and the production and so on. So let's get it started. Let's just understand what is it all about when we are architecting a solution using big data or anything that is related to big data or else data services using software.
Yeah, we
So
can
my
see.
first question is all about like intelligent systems are always there, but there are features in production that is always a bigger piece of a puzzle, which not just Scrum Master takes care of it. Everybody becomes part of that production environment, right? Everybody in the company, everybody who's taking care of that feature is already taking part of that features, how to upgrade it, update it, and things like that. So, what is it all about when we are considering such kind of an hefty system, an intelligent system built on a production, and what are the different features that we need to look at when we are thinking about that production environment?
Do you mean how we take intelligence feature into the production?
Yes.
Like different aspects of intelligence. So to begin with, if I say we take a lot about data first, like we say intelligence, we don't go intelligence as a something in silos. We take intelligence as a value add. See, if you say current software system thing, whatever you can write the rule on, you have saturated on. You have food delivery service, you have taxi services, you have payment services, everything. What else? So what is the next value add? So we need to understand from the user what user actually, who are your customers, where they are, what they are looking for, where they exist, and how they are interacting with your systems, your services. Maybe you could have just one app. If you maybe you're a small company, small startup with one app. Maybe you are a tech giant with multiple apps. You are sent across multiple places, across multiple domains, but your users are using your product to get some value addition. Are we able to capture that? So that is the first point, to understand from the user. And today the data exists in the systems. Like every Facebook click you do, every order you put on the Swiggy, every bike ride you order or put on the Uber, everything is getting captured. So you don't have the limit to the data points we have, but can you collect that? Can you store it somewhere where those data points are queryable? So that is the first part, getting right set of data in place. And you just don't go on, you have some hypothesis, you do some early set of analysis to understand, like some you have some hypothesis, your teammates have some hypothesis, other people have some hypothesis. So you go on step by step on each hypothesis. You actually test on a data, and then when you test on a data, you got some insight, and you build some hypothesis from the data what you got. What maybe user is coming to the checkout page, but user drops out. Maybe user add into the Amazon shopping cart but never end up buying it. Maybe there could be the reason, and you have some hypothesis. Maybe the shopping cart is too much effort it takes for you to click on the purchase order, or the way your shopping cart and the security system behaves, or something is happening in between. So why user drop at that point? So trying to get into those data and build some hypothesis. And once you have the hypothesis, now we need to interact with we need to get maybe we have some feature idea. This is the feature which we could introduce. So we immediately put it, like you just build a very small workable version like POC, not working 100% fine, but yeah, you work on a version on that could be, and see how people are interacting. And then with multiple data, you build a models. Like if you go to ML part, there would be that model could be on your application. That model could reside outside your application as a service. So where those are all there are, and then there is an ML engineering, whole ML engineering aspect come into the flow. So you need to deal with those ML engineering aspects. Then you need to deal with infrastructure, a lot of infrastructure, because software engineering is one way going, but here you have to deal with the high end computing ML models that are already running. And then you have a infrastructure challenges as well. You cannot make m cross n calls with these models, because every time this model execute, you have lot of computes goes on. So you cannot, maybe you store something with you have to make, being data oriented, let's see what are the top 20% thing, or what are the top 5 things which are using 70% of the time. You put that in the cache, so that this is, I think, something being followed in Google search as well.
Yeah.
Most of the your search result are being stored in your in, I think, some local cache or some with your ISP something.
Yeah.
So not 100%, but yeah, something similar follows. So that, but the model which is being trained is very heavy. So you cannot execute. So you do all those sort of engineering, and then you test it around. You test with your internal users. You test with you run maybe you run some sort of experiment and see if that is changing, and then how you iterate on it. So that's, I think, the one way, if I say, like from beginning with getting data, testing your hypothesis, seeing where the pitfalls, or getting some idea to having some multiple perspective around it, and then trying multiple product ideas or feature ideas that could adding some intelligence, because now intelligence is all now continues to be a value add, because we have saturated on what we could do on computational basis. um, I hope I'm making some sense to it.
Yeah, it's all about that. It's all that business logic that we actually deliver as quick as possible. More we try to deliver a business logic, more we try to architect the solution that is more feasible. These are the ways in which you can actually think about how can I make sure that my data builds me a lot of money. It's all about minting that money, right? So now the question is all about, like, challenges in iterations of solving software engineering, and also how is it actually going to affect the ways in which we are architecting the solution. Because a lot of times when I think of anything as a system design is going to be humongous. That's what we think, but some systems are really simple. They are heavily stable, by the way. Like, some simple designs have really been much more stable than making it more complex by adding more complexity onto the system. So what is it all about when we are talking about a lot of challenges which we face in iteration of software engineering? And also, why is it important in order to iterate as quick as possible? Because when team tries to make some DevOps decisions, it's not like one fits the all. It's also about discovering what fits the best to us. So what is it all about when we are iterating in a software project?
Mm, I would say it's not one fit all or one fit best. It depends on your need. If you say there are few organizations that will ship, that has the capability to ship next day. Like today, I coded that down. Your startup, if you are with a startup, you can put that to the user next day to test it out. If you look into a large or kind of stuff, they will take from being the code complete to use to the real user take having the first glance of it. It at times takes a quarter of the time, because they have so many compliances to follow. So it depends where you are placed, but yeah, are you optimal? Can you iterate as fast as you can? That is important. And there, I think DevOps and data both have very important role to play. DevOps, if I say DevOps, as I think this is defined within Microsoft as well, DevOps is a DevOps is a journey that has 3 pillars: people, process, and tools. You need a culture where people will enable people, create process, and give them tools to ship the value to the end user as fast as we can. So when this pipeline is there now, when this pipeline is smooth, is friction free, or it can never be friction free. That could be an ideal thing. But when the friction is least, like I push in a code and I get all the reports I needed about performance. My pipelines have all the security steps in place. My data which I am accessing is all compliant. All the user authentication, everything I'm doing with my data. The data which I'm flowing outside the user boundary is with user permission. Every process is defined for all the steps, and then we are able to make code shift faster. We make sure engineers follow the relevant set of guidelines, not very strict but not compromising on the quality as well, to make sure they could shift faster. Because if we put it very strictly, you have to follow every set of rules. Engineer writing the code for an engineer could become slower. But if we allow bugs get in, we don't want that. So we need to figure out that balance, what ship, with which speed we want to ship in. And when you have that particular flow, you have a least set of frictions in your pipeline, like from writing the code to pushing it. Are you enabling your teammates enough to review it faster? Or are you putting are you or your teammate is going to say, no, I have to review the code? That's a hurdle. So I think this is an another analogy. But this happened with Facebook. Very early, between 2007 or 8 something. Engineers are not focused on hiring. They don't they Engineer were all what they're all focused on: writing a good quality code, doing all the technical and exciting stuff. But they're not focused on hiring. But then their leadership realized that, and they have to shift the culture. So they make sure engineers shift the culture, they feedback. Because once you build the team, that is the high leverage activity that was there. Once you have the right team in place, that activity plays for multiple years than writing the code. Similarly, if you have that pipeline in place, engineering pipeline, your teammate is feeling happy to review your code. So, and your code is getting checked in. You have the team which is helping you get the security, your system in security in place. Are they enforcing too much, or are you resisting too much? How you are balancing that need? You have your DevOps engineers, people working with SREs. Are they have put the right set of tooling in place for you to go friction free, or you have to struggle with the documents to initiate? Like if I'm talking about in Azure DevOps, like to push something to production, you have to go through a pipeline or some release pipeline. Are there enough friction? Are there enough things in place which makes the friction least? If not if not friction free, that optimizes you. And then I think there are examples, like I think Amazon has a very good culture. I think they could iterate very fast. I think somewhere I was reading some time back, within a week I think they could iterate and test it out anything. And Netflix have very great engineering culture. Yeah, I think DevOps culture, it's all out about Netflix. So yeah, it's very basically actually what your org requirement is. And Microsoft and Google deal with a lot of sensitive data, so they have to go slow. So that's I think if you have any follow up on that. But
Yeah, no, but like, teams forget to iterate faster sometimes, right? Sometimes
hmm,
like, legacy systems are working fine, it's minting good money, but like there is an hacker who is already ready to exploit all of it. That's how agile the system is today. That's
hmm,
how agile system has to be. So I wanted your view on agile system and the data engineering part. There is a huge difference between what agile means in a software engineering in a typical software engineering problem statement, but what an agile means in a data engineering and a data science perspective. What do you feel about the way in which we are going faster and quicker with respect to the problem statement that comes in? So, how should modern day teams approach it? Like, how did you learn it over a course of time? Because you have seen different different companies, they have their own culture in place. So how are teams evolving today, and how should team iterate today as quick as possible by having the principles of agile in mind with respect to data science and the data engineering perspective?
If you say data science and data engineering perspective, people are still experimenting. We haven't defined, but what we try to do is these are all about getting more numbers. Like even if you remove data science or data engineering per se, if you just go for the building a product, so you go data driven, be data first, like use data as the source of truth, because everything can be perception. Like say in a room 10 people are there, out your sample size is 10 people, out of 10 7 say we go for feature A, 3 say we go for feature B, majority wins. Or if it's an hierarchical, the person on the higher in the hierarchy is opinion matter, for any sort of reasons. So those were dead approaches. You cannot really go them. You need real numbers to tell you what to do, or the numbers which could guide you with the hypothesis which you could test. And if you have a strong data system in place where you can literally go and query, let's say I have a, because the events are happening every click, every ride share, every food order, every documents getting created, every task getting created, and every email coming up. So lot of events are happening, and there are like totally unstructured and varied in nature. So you have a lot of data, but can you pull it in your system, collate it, format it such a way it's easy to access for a data scientist lying down. It's easy for to access for a software engineer who is looking for some result, like what has happened in the past, something is, it is easy to access for a program manager to see what feature, what user is trying to do. So yeah, so if you set those data systems in place right, very rightly, and let others query those faster, get the result they wanted, or the things they wanted. So having a strong data engineering pipeline that could from the that run the job every day, every hour, or whatever. This depends on the nature of the organization and need of the business. If you have those systems, if you have the people with the right mindset to build the feature, to create next exponential value add, understand the customer first. So that is important, what people are trying to do through the data, through the things which they are doing in that, and you have a data for that, and that data has to be stored in very secure way, understanding the user privacy. You have to just what you are getting, you cannot get every, you cannot go and log everything about the user, not all the sensitive details and all. You need to understand users concern, you need to ensure how your data are coming into your system. So managing that, build and understanding the pace, like the way your storage can handle, and the pace the input is inflows are coming, those can be very different. So how you manage the infrastructure in between and ensuring your strong data system in place. You have the processes to exploit those data systems, get some initial numbers, and once you have it, you could have the hypothesis, and then you can then go ship a feature, test it with some user, give it to test with the things how it's working, and then improve on and see if that idea is working around. And having an experimentation at the end of the before you release, you just cannot release and say you just see and see after release, you see if numbers are there. But if you be in an experimental for a buffer of some time, see if do an A/B experiment, see what different users are behaving, how that is impacting, understand the data again at the start with the data, and then again at the end, see how those data have impacted the metric you want to. Maybe you want to increase the number of user who are using it, you want to reduce the number of dropouts. So how though, where you begin with the data, where you are ending with the data, are you have the right data system in place, are you have the right processes and the infrastructure in place, are you have the people who are willing to go for that. So I think that's how you can if you have all these things in place, you cannot be friction free, but you can optimize for the frictions. And then I think when you can iterate faster, optimizing and iterating fast, you can see you can do more things. And when you have the ability to fail fast, then you can see right thing coming at the point, and you're creating right set of value for the users whom you are trying to deliver the value.
Yeah, that's true. That's true. Organizations need to at least adapt to the new thing that is always coming in. So it's not about like how big is your system, how complex is your system, how secure is your system. There is a new way in which system always keeps evolving. So it is all about like importance of automation process, which is there in the software engineering, and also building intelligent system based on that. Like today when you think of all these iterations that are coming up in the market, we think that okay, fine, we use this tool, that tool, one person is endorsing their product here and one person is endorsing the product there. There are multiple tools coming up. So I wanted to know what is the importance of automation in the software engineering and building intelligence and creating exponential values using all these automations. Because a lot of times when I think about this, I think about MLOps as one of the form factor of all these things that we're talking in terms of the software. Because ML projects needs to be built, tested, and has to be shipped to the different environments that we are having. So it needs to be promoted at the end of the day. So what is the value that and software engineering problem statement in data science and the data engineering world brings, which also starts affecting the way in which we are delivering values or the business values to the problem statement? So how do you see that automation building and value in automating faster, iterating faster, testing faster in a production environment?
So I think the way I have shared the what is DevOps for the Microsoft, it's enabling people, setting up the processes, and creating the tools that will help the organization uh, create a real value add to the end user faster. And if you say DevOps, a DevOps is a lot of automation. And when DevOps can automate a lot of things, my check-in, it, I put, I check in, I auth, code gets secure, all the pipelines run behind the scene, all the security checks, all the privacy check, all the logging metric, everything being checked in, all the reports, my performance reports, my code coverage, my test, everything got settled up. Someone has to come and just review the code points of my code, like my fellow teammate can just review it. Like if it's structured in such a way, like all the thing which the problem I wanted to solve, that's also in the place, and all the information all in a very crisp format in a single screen available. And the moment we put hit, the pipeline goes to the release, and it's continuously to deliver you the automation. But what else can you do on top of once you automate it? Let's say if you have a system and that can ship, that you can release 3 times like you have an APIs, your APIs could or you have a backend services, those could get released 3 or 4 times a day. That's the value. Like that's faster we can move. Like if you have a bug, you got a bug in your bug reported, and it's not the release time, it's not the engineering effort that is there. People have the systems in place to right people get it, we understand the issue, we look into the logs data or whatever, and we fixed it. But how much time from there it takes to reach the customer? So that is important. If orgs can figure out the processes to ship that value in, let's say, twice a day shipping, or if it's an application every week or every 2 week, or however, depend on the org is. Like if it's an end user application, you cannot ship 4 times an end user, you don't want user to update their app 4 times a day. So if you can make that processes simple, you have a data with you in your dashboard. If you can use those this is your DevOps can help you automate everything, And when your DevOps is connected to the data and intelligence in place, you see, before you reach, you push your job to the pipeline, your data will tell you, hey, I'm thinking this could break up in the production, and give you maybe something, give you some hints, and and you don't allow the things to merge to the master. You have to put, maybe it will give you critical breakdown, critical risk. What is the percentage of critical risk? Let's say if that critical risk percentage is below 30%, then only you can merge it to the master. Yeah, there could be false positive, but yeah, we could have at least 70% things done. We could run multiple checks to see what is the point we are missing something. So yeah, if those things are in place, you can automate the flow. And at the end, if you see artificial intelligence, machine learning, all this comes in, or any intelligence product comes in, when this system is high process oriented, so your DevOps will automate stuff for your engineer. But what is the next value add for the user? That's an automation. I go to a store and I see, yeah, this I need to buy. What I need to buy, I can see the recommendation list, or I scanned it and it gets added to my cart. It gets added to my cart. Uber knows my favorite destination, instantly recommend it. And maybe while I driving, Google Maps told me, don't take this turn, go long and take the next turn. There might be some, this is a peak traffic time, something like that. That's a value add. You are giving user more based on user past behavior or behavior of the surrounding, the additional insightful information user need to take the action that will increase the overall value to the users, or to the people, customer, whoever your end customer is, whoever you are serving value to, while with building all these engineering strong and scalable engineering system. So I think that's how, if you automate stuff, it will only start creating exponential value. And you need to start thinking, what is the next exponential value, what I could automate, what is the roadblock, or what is the bottleneck that is stopping you from creating an exponential value, and how could I get more data about that bottleneck, and how could I add the processes that could automate that bottleneck. I think that's how, I think if you look, you can see automation bringing more value to the value to you.
Yeah, no. So, we know that there is algorithms which are iteratively increasing. Market is actually perceived in a different fashion. There's always a feedback loop that comes from the industry, that comes from the people who are testing on production as well, like who are testing these applications as well. It need not have been QA test or any environment. It can be also in the production. People are using it. People are coming with the feedback, and also scientists are observing it. So based on that fact that we have so much of iteration of the feedback loops that are coming up, so how are actually AI algorithms and the techniques evolving today? You take self-driving car has its own needs, and now there is an improvisation in the technology and the techniques that are used in building such kind of a system. That's a complex system to a person who has not worked on. To a person who has worked on, yes, they will be a part of a bigger puzzle which is yet to be solved. That is how it is, even in the same in medical imaging. So how do you feel? How do you think that there is an evolution in a market in the way in which we are architecting a solution using AI or as machine learning, or is the evolution of the existing techniques? How are they happening in the world?
So to begin with, maybe I could say, like, do you use Grammarly, or maybe Google Docs
Yeah,
or
yeah, I use
Microsoft
both.
Word?
Yeah, yeah,
Whenever you
yeah,
keep writing, uh, they are started getting corrected in behind the scene. Or when your email is writing, it is start suggesting you whatever. Most of the time, with 70 to more than 80%, I think, in my experience, that's
yeah.
more than 80%, it's getting evolved. So, and then you see, you have a self-driving car, you have a automatic cars for the city roads. Like, you have an automatic car for the city road, which have all the cameras and take everything in the context. And Maybe in a heavily traffic environment, those are the best cars to have. So how these things are, the thing is, I currently what the focus of the community or the research communities build a general knowledge of the world. So if you say the text, we have multiple embedding systems like embedding system like Turing from the Microsoft. I think BERT was from the Google. OpenAI has one. OpenAI has I don't exactly remember the name, but OpenAI has one. And all this started way back. I think
OpenAI is DALI.
no, I don't. Just
DALI
give me a sec.
was
OpenAI. Just give me a sec. I'll give you the name.
OpenAI. Okay, not the DALI. It was
No.
GPT-3.
Yeah. GPT.
Yeah.
So those are like billions and billions of like they have trained with the used data and billions of parameters being used in the deep learning models, and they have evolved to bring to a general knowledge. And on top of it, you can add single layer with your data and fine tune it to your domain. So that's how we have evolved over the years. So how you say, if you go 1990 or 2000, when G when GPU was not when GPU was not there, doing a small compute. Let's say if you say deep learning, it's trying to mimic the neurons which you have in your human neurons. Same thing. Doing one compute was a big thing. Image, if you say what if you give set of images, classify them 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That was a humongous toss 1990 2000 when GPU was not there. Today we have a 2007 onwards when we have a GPUs and all the high computes and everything. We are doing more per unit compute, higher compute. We are processing more data, understanding more data, running more complex algorithm, and we are not completely built, but we have built the knowledge of the Wikipedia. We have built the knowledge of the emails. We have built the knowledge of the documents. So, and when you go on top of it, you are in the financial industry. You just put up some financial document and or just make more narrower and make it like with one layer or with like very little extra effort. You want a medical domain, you can do the same. Similarly, this is what you can do for the language, and this is what also people are trying to build a general knowledge. Like it's not 100% complete. We don't know complete human language, but from existing documents, we have built something. Similarly, for the for images, this is, I think, one of the top of the mind thing. One of the top of the mind thing for the scientists. Like, can we somehow build some general knowledge from the images? We have something, but that is not like we build general knowledge for the images. And then the third thing is data sharing. Models are very heavy, high computing, and we have data is also too much to be one there. Can you do data sharing and model sharing? Can you cross do like something like parallelization? How you can do parallelization, and how you can do synchronization? Can you train different set at different different devices, different computers, like, or different systems all together? Come come join is like something like something like Hadoop map reduce architecture. Can you, some few things are try, but can you do more on this? So those optimizations are being in there. And then there are real-time application like self-driving car. So those then again comes in generating the real world data with quality. Those are the again, that is important, that is being going on. So yeah, these are is as per as much as I knew. Like, these are the few things which are important. And then yeah, you're building the model, and yeah, always your model are getting more complex. You're solving more narrower problem, more specialized problem, and you people are iterating over it and solving within the text, within the images, unstructured data. different model, different mathematical models you're solving. You're solving the data problem. You're solving the engineering aspect, like how you put this model into these heavy billion parameter. You cannot put just billion parameter model into an app. So how will do that? How you'll do the pre-compute, all those pre-computes, how we'll go all these engineering aspects again. Yeah, but that's separate thing. But yeah, these are, I think, the few things which are coming. I hope I
Yeah,
could share something valuable.
yeah, like when I think of the ways in which people are perceiving the production of an AI system which is already built, something like it's not a complete AI on a brain or on a burning box. It's something like we are trying to iterate based on the feedback that they're getting. When I saw what was used in the first version of the self-driving car, the Mercedes-Benz truck, it's still A star D algorithm, D star algorithm, things like that. I'm like, what? These are simple algorithms which really made so much of buzz during that point of time. We learn these today and we still evolve using these kind of principles. If I see, it's still the neuron principles which are there, but we are just adding so much of complexity on top of each other. Like, feedback was added, back propagation was coming out, learning rates started changing, the math behind the complexity started changing. The huge way, like I see RZ coming out with 150 plus what do you call the publications every single day. It's something like, AI is still evolving. Like, we have not completely understood the brain, but our humble attempt to build that on a burning box like CPUs and the GPUs, that is making a lot of impact. That is making us to iterate as quick as possible. Like, what I saw between 2017 and 2022 today is completely different. The way companies are approaching problem state. So, like, do you have any views about like the ways in which companies are architected today? Like, will it really change, or else will it be something like iterative for a longer time, and now there'll be a time where they have to stop that iteration at one given point of time?
AI is very, like, very narrow, very small. I'm not like when you have to stop, you haven't solved anything of the pie. Like, there is no general system which could read all the invoices, all the documents. So your system still, you have to write train an individual set of documents, like an individual specific format documents, lot of documents. If I want to do legal, I have to put hundreds of legal documents. I want to do financial, I have to put hundreds of financial documents. There's no generic system which can read all the document. There is no generic system which could go through any road, anything. You have to build specialized. Still, you're not even solving a single domain. Not the specialization, very narrow specialization we could solve currently. So still, I think there is a lot of research to go on. I am not sure about how much compute efficient those will be going further, because we need to somehow say, like, we cannot go and compute billions of endpoints for everything. We need, like, there are concepts like one shot learning, zero shot learning. Those are like based on some existing pre-work which has been done, and reusing those existing data and putting up in your own data and just getting it. So yeah, these are more about what data tells you, and you are using computes, mathematical representation to real world knowledge to see what you can build it. So where it will be stopped, I think if you follow the scientists, any of the scientists, no one is of the opinion we are anywhere further solving the human level. We are very far from human level intelligence in terms of compute. So I think we could solve a lot of business use cases, lot of things we could automate currently. But I don't see anywhere that there is a human threat or anything gonna happen with AI, AI, machine learning, deep learning, and all those things. These are still a technical field, with my view currently, for a
Sure.
significant term we are going to live in this planet.
Yeah. Thank you so much for sharing what are the topics to be covered, because a lot of times, I get puzzled because you have done so much, and I was like, can I ask you regarding the DevOps? And he actually gave me all the topics regarding what I should be covering in the podcast as a question. And, it's an honor, because a lot of times you get puzzled because what people are doing. And I think probably he has shared the best insights for my podcast. It's going to be efficiently used in all my future studies as well, because these insights were supposed to be there for me for a very long term, because a lot of times I miss out on something. A lot of times probably he might miss out on something, and he's really updating the people like me and people like others who are still there in the industry. I think thank you so much, Saurabh sir, for doing this podcast. Means a lot, and of course it's a lot of iterations of calls that we had on LinkedIn, and we just connected finally and had this
Yeah,
amazing podcast.
I'm
It was so
really
nice
sorry.
talking to you.
It took us more than a year to get into this call. Busy with
Yeah,
quite a stuff. Like,
yeah. That's how it is, right? It's an humble attempt from my side to understand what is this world actually architecting today, and what should be my approach in architecting it the right way. And I think this is something which is actually good that I'm doing right now, so that I can understand, I can educate more folks using these kind of platforms.
yeah,
Thank you so much, sir.
thank you so much, Vishwas. I think even I'm getting some perspective which I shared and in the meet in the time. So yeah, I
Sure.
while speaking it, my mind was flowing. Okay, this is all you are doing, but I didn't realize. Oh, this was the process. Now I know this is a process as well. Yeah, thank you so much.
Sure.
It was great time.
Sure.